Apollo Control at 18 hours 29 minutes. During the change of shift press briefing, Flight Director Gene Kranz reviewed the status of the mission with each of his flight controllers. Everything essentially normal at this point. The Flight Dynamics Officer reported that they have not yet gotten sufficient tracking on the S-4B trajectory to give an impact point based on tracking. We should have that in a matter of hours, and we'll get a report as soon as a set of coordinates for the S-4B impact are available. Also, Capcom Gordon Fullerton read up a news report to the crew. And it's been relatively quiet for the past 5 or 10 minutes on the air-to-ground line. We'll replay the accumulated tape, and as soon as we've caught up with the tape, we'll stand by for live conversations with the crew.
It's 5 in that storm. You concur 5 in that star, Houston?
Stand by, let me check.
I think it was. I'll take another one just in case. Okay, Gene, CMC auto. Okay. All right. That's right, no problem. Plus 99128. 28, enter. Plus 12885. 12885. Okay. It. It's okay. 180 option, no. Computer, take me to Beetlejuice. Okay, this Earth's far horizon. Yeah, bunch of oil. Yeah, good. Okay, says we're there. Okay, see the old spiral cup of the subsolar point. Okay, it's a far horizon. Double line is down in the Earth. 280 up. Pitch up a little bit here. Okay, didn't do such a hot job of putting it on there. You want to go CMC free? Okay. Give it a blip that way, and a blip that way. And a yaw that way, and 2 yaws that way. Holy mackerel. Yeah, that was a good march. So that was... Cordy, this is LMP. Hello, Houston, 17, how you doing?
Go ahead, check.
Yeah, you got any news today to read up to us?
Yeah, as a matter of fact, we have a little bit made up here. I guess, well, on the personal line, we checked with Barbara and Jan and the kids, and they're all back home safe and sound, and they mentioned that they're going into their own personal quarantine period. They're glued to the squawk box. Over.
Okay. I was afraid you were going to get too personal there for a minute.
I'll run down a few quick summaries of this morning's news. Former President Harry Truman has rallied slightly despite his weakened heart and labored breathing. His doctors report that their main worry is whether his heart is strong enough to withstand the physical strain of 88 years. Despite the slight rally, Truman's condition is still considered critical. In Paris, Henry Kissinger met with Hanoi's Le Duc for 4 hours yesterday and planned secret talks. Paris newspapers report an imminent ceasefire, but neither Kissinger or Tho indicate that this is true. After the 4-hour talks, Kissinger shook hands and his aide, but I had a little typo error here, but neither representative made any comment concerning their meeting. At Camp David, Maryland, President Nixon's press secretary, Ronald Ziegler, said that Kissinger and Nixon are in close communication by cable concerning the secret peace talks, but Ziegler declined to provide more information about progress in the talks. President Nixon selected Claude S. Brinegar, a California oil executive and a doctor of economics, to be Secretary of Transportation, succeeding John A. Volpe. Volpe will become the U.S. ambassador to Italy. Here's one concerning last night's launch. Mrs. Spiro Agnew reportedly made a wish on a falling star just before the delayed launch of Apollo 17. Sitting beside her at the VIP viewing site was Barbara Cernan, who said that she was nervous when the liftoff was postponed. She added, but Al Bean was there with me. He said not to be concerned. Mrs. Cernan was accompanied by her daughter Tracy and her mother, Mrs. Jackie Ashley. Mrs. Ron Evans, who saw the launch with her children, Jamie and John, said that she was never worried because everybody knew what they were doing.
Good summary, Gordo. We thank you and our best wishes for the return to health of Mr. Truman.
Roger.
Gordo, we were figuring up here we probably launched on the 6th of December in Houston and on the 7th of December in Florida.
That's right. You call it right.
Okay, CMC Auto there, Gene, please. Boy. Okay, let's use verb 2-3 enter. What do I do there? Enter, let's use 1-1-0. There, okay. Verb 2-5 enter. Gamma prime Leonis. Okay, minus 8490. 84900, I mean. Plus 40299. Plus 40299. Enter. Plus 34176. Plus. Enter. Okay, proceed. 202, no one time, 118. Okay. There already. Second, I guess. We'll try that one more time. And CMC Auto? Yep. Are we at 196, 306? Oh. Gordy, you're still there? Okay, that's right.
Go ahead, Jack.
Yeah, I mentioned to Bob yesterday how, as we moved away from the Earth, how fragile a piece of blue it looked to be, and that impression certainly grows the farther you get from it. I wish everybody could have a chance to get that impression. Things might go a little easier for us.
Roger.
Okay, Gene, you want to CMC free? Must be making the vector worse and worse instead of better. Well, it was on the sub-stellar point that time, except it's halfway through the Earth almost. Not really. Hey, Gordy, we haven't really had a clear and detailed description of what you or somebody else saw at the launch in terms of the lighting around the countryside and the extent of the flame and how long the exhaust was out of the S1C. Do you have anything to add to that?
Well, I can give you my feelings right away. It was a spectacular sight, and no doubt about it. I'd say the level of illumination would have made it easy to read a newspaper or anything like that from our vantage point near the VAB. The plume itself actually looked no larger or even any brighter, really, except in contrast than it does on a day launch by comparison. But well, the effect, I guess, is about what I expected, just trying to extrapolate previous launches into a nighttime situation. The weather was very clear. That was one advantage gained by delay in the launch, the 2 hours and 40 minutes that you did. By that time, there were very few clouds around at all. And we could see brilliant flash there when the first stage cut off and the second stage ignited. And I lost you visually probably 4 to 5 minutes into the second stage, as best I can remember. Part of the problem was the brightness of the plume during the first stage. It kind of burned a spot in my eye, and so then I had reduced efficiency at looking for a small point of light from there on out. Stu's here with me, and he was watching it too. I'll see if he has anything to add.
Stu who?
He said after that comment, he has no comment.
I'm sorry, Stu. I can't believe that. Stu always has something to add. Houston, in case you just noticed, I forgot the Bird 67 until just now. Although in reality, all we're trying to do here is get a delta H measurement anyhow. And Houston, do you have any feel yet for what the delta H is mine has been?
Stand by, Ron. Ron, it's Houston. We're not going to be able to give you a handle on the delta H until they have a chance to take all the data and reduce it and work it around a little.
Oh, okay, that's mighty fine. Okay, Gene, you want to CMC auto? Let's see what's the next star here. Cullinan, I guess. Okay, Earth far horizon. 23, enter. 1225, enter. 50. Plus 70 73. Okay, that is the unit vector of the star. Okay, it's a 180 option we don't want. We need a real option. I guess we're good. Houston, you must be getting all the good data without the high gain, huh?
That's affirmative, Ron.
Okay. Okay, let's enter that. Okay, Gene, you go CMC free now. Yeah, that's about a half a sextant diameter above the horizon. Substellar point looks pretty good though. Hey, guys. Yeah, not yet. Yeah, it's on there. Oops. Hey, CMC auto, please. Last star. Oh, that was it. We're gonna go back to the calibration attitude. Okay, CMC auto encaged, and away we go. Hey, we gotta dump the wastewater too. It's 10%. Uh, 164, 301, and 318. That's a optics calibration attitude, the one to start with again. Put the landmark line of sight on star 22. And also the optics line of sight with optics 0. Let's see, I don't zero the optics, I guess, first. Okay, Houston, looks like optics calibration there is 995. I get that half the time and 997 the rest, so we use 995, I guess.
Roger.
Okay, Houston, you ready for some purges and dumps?
Let me make sure. We're standing by.
I had my clock on the wrong scale. Is that about 2 minutes, Houston?
That's good, Jack. Did you copy that, Jack? They said that was fine.
Yes, sir, Stu. I copied that. How are you?
Okay, swinging.
That's good to hear.
Sure, I'm enjoying your descriptions.
If I could get Ron off his work with the optics, we'd look at the reservoir, but that'll come. Right now I'm seeing all sorts of little ice crystals of various compositions that are moving around, and every one of them bounces off the limb that I can see. No, none of them stick. But I noticed that some of them will go into a corner with a fairly high velocity and either be turned around by a double bounce or just get lost in the corner and have very low velocity when they come out.
Roger.
Most of them look like they have at least a foot or two per second.
Roger.
Hey, Jack, I was surprised when you said when you got Ron off the optics. Don't tell me that Ron's going to let you look through his optics.
Oh, heavens no, we just moved the windows.
Okay.
That's for sure.
The Capcom at the present time is astronaut Stuart Russa, backup command module pilot for Apollo 17.
Apparently you do get some particle collisions because some of the trajectories are back towards us.
Okay, we're waiting for the explanation of that.
Well, I think it's because the particles are, some of them, are bouncing off the limb and get out into the stream, which normally would have no collisions. How's that? You can say it's not very good. I don't care.
Got to use tack there.
That animated description of the behavior of a cloud of ice crystals drifting along with the spacecraft was coming from Jack Schmidt. Apollo 17 at this point is 81,654 nautical miles from Earth, traveling at a speed of 5,972 feet per second. And we see from the telemetry data that the fuel cell purge called for in the flight plan at this time is progressing. This involves flowing, in this case, oxygen at a high rate through the fuel cell for a short period of time to remove any buildup of contaminants, and is a routine maintenance or housekeeping procedure. Same thing is also done periodically for the hydrogen.
You can terminate the purge on fuel cell 3, O2.
Yeah, I even forgot to listen for the ding on that one. Thank you.
We'll be having a communications handover to Honeysuckle in about a minute and a half.
Okay, Gorham. That's great. Next time I look at the Earth, I'll see what's happening in Australia. Okay, Houston, we're starting our wastewater dump.
Okay.
Wish us luck. Wish us luck. Yeah, that really goes out.
Can you give us poo and accept, and we'll give you a new state vector.
Probably need one after all those marks. Okay, you've got poo and accept.
Roger. Okay, the vector's in there. It's your computer.
Okay, Gordo, thank you.
This is Apollo Control at 19 hours, 7 minutes. The crew aboard Apollo 17 has completed the next item in the flight plan in the way of housekeeping duties aboard the spacecraft. That involved dumping waste water. Water is accumulated in a 7 to 8 gallon tank on the spacecraft, which is produced as a byproduct of generating electricity in the fuel cells. These fuel cells generate quite a bit more water than the spacecraft is able to consume for cooling and for crew drinking purposes. The excess goes into a wastewater tank, and periodically it's dumped down to about 10%, and the crew has just completed that activity. We're going to take advantage of a relatively quiet time in the flight plan at this time to replay a portion of the air-to-ground conversations with the spacecraft, which included, among other things, a rather detailed description of Earth given by Jack Schmitt, some weather patterns. This replay is necessitated by a problem that we had with a portion of the public affairs release circuit between 4:40 and 5:05 p.m. Central Standard Time this afternoon, in which a portion of the release circuit did not receive the air-to-ground. And for the benefit of those people who missed that portion of air-to-ground, we'll replay the tapes at this time.
Okay, start 21 and no 988.
Right, and over on the right where it says Mirac, you can write in Alphard. That's what 21 is.
Okay.
Okay, now down on the next page at 18 hours and 20 minutes, where it says optics calibration attitude, we got to put in the same thing as same changes above. We want instead of 175-298-330, change that to 164-301 and 348. High gain of minus 48 and 315. Over.
Okay, 164-301-348, minus 48, 315. Over.
Okay. Now, about 10 lines down, delete charge battery A. We're going to leave battery A charged for a while longer since we used up so much of it on the pad last night.
Okay, delete battery charge A, and you want to leave it on B.
Yes, right. Flip the page, might as well clean up all these checklist changes. At 19 hours and 40 minutes, change magazine Kilo Kilo to magazine November November.
Okay, that's done.
And then skip a few pages to 24 hours and 30 minutes.
Go ahead.
And just above the CSM Systems checklist call out there, write in charge battery A.
Okay, I got you.
And we'll be leaving it on battery A all night long. Okay, that's all the flight plan changes. I've got that flyby pad when you're ready.
Okay, I'm all set.
Okay, its purpose is flyby SBS/GNN. The weight is 66839er. Plus 121. Minus 02. Correction. The yaw trim is a minus 012. Ignition time is 081172103. 981 is a plus 00911. plus 02041 plus 0459er3. Attitude is 121, 153, and 321. Apogee is NA, perigee plus 00212. Delta V total of 05108. 117. 05063. Sexton star is 26. 0965. 339er. Boresight star is NA. Noun 61 plus 1557 minus 17500. 10niner. 36243. And GET of 05G is 1532411. GDC aligned stars are Sirius and Rigel. 256 152 069er. Ullage is none. And for remarks, number 1 is burn docked. Number 2 assumes PTC rest mat. Number 3, LEM weight 36281. And number 4 is assumes no mid-course 2. Over.
Hey, Gordy, you read that?
I haven't heard anything since I finished the pad, Jack.
Okay, I'll push the other button then. Okay, your readback. Flyby SPS GNN 66839er plus 121 minus 012 081172103 plus 00911 plus 02041 plus 04593 121153321. HA is NA plus 00210 05108 1170563 260965 339er. Boresight stars NA plus 1557 minus 17500 10999 36243 1532411. Sirius and Rigel 256 152 069er. No ullage. Remarks: 1. Burn dock. 2. PTC rest mat assumed. 3. Limb. Weight 36281. And 4. Assumes no mid-course 2.
Okay, one correction on perigee of noun 44. That's a plus 00212.
Okay, 00212 plus.
And one additional remark, this results in a 187-mile perigee, paraloon.
then.
Okay, for general information, we're planning mid-course 2 tomorrow at about 35:30, and it should be about 10 feet per second.
Okay. Strangely enough, that's even scheduled at 35:30.
Raj. One reminder to open the waste stowage vent valve as shown on the at 17 hours here.
Oh, okay. We were going back to clean up. I think we owe you a Lyle canister change, too.
Raj, we concur with changing it.
And Houston, Apollo 17 will maneuver to the Optics calibration attitude now.
Okie doke.
It's funny, you eat potato soup, and all the soup is all around the outside of the bag, and you get a little hole right down through the middle of it. Yeah.
How about that?
It's just like a 1G. The spoon isn't quite long enough to reach the bottom without getting your fingers on the side of the bowl.
Right.
Gordy, I don't know what your weather's like down there, but from here it looks like you're probably overcast today. Might even have a pretty good storm going.
Oh, it's gray and cold and a little rain, so your call is correct.
Yeah, it looks like Mexico in general is pretty nice, although there's a band of east-west trending clouds that start from the Gulf of California, across Sonora, probably up through New Mexico and over into Texas, and as far around as I can see. Southern California looks like it's in pretty good shape today, but Northern California looks like it's probably overcast. And a major system probably associated with that stretches into the northern western United States. But a band of clear weather looks like it stretches from Arizona right on up through, I would guess it through Colorado and Kansas and probably into the Midwest pretty well.
Raj, your regular human weather satellite.
If Ron had just stopped his maneuvers, I'd tell you some more, but the Earth just set behind the limb.
Raj.
More specifically, it's set behind a rover, which may be a space first. Pretty impressive storm system down off the west coast of Antarctica.
Roger.
And Houston, the canister has been changed. Number 3 is in A, as per the earlier flight plan instructions.
Okay.
Sorry we were late, but we got a little tired last night.
Jack Houston, we'd like you to go ahead and get that waste storage vent open now so we can keep to the schedule on cabin enrichment.
Okay, Ron's getting that. Keep nagging.
Thank you.
That the same as I had before? 9.
This is Apollo Control at 19 hours 33 minutes. That completes our replay of the segments of the air-to-ground that were lost on a portion of the Public Affairs Release Network earlier today. During that replay, we accumulated about 5 or 6 minutes of additional tape with the crew. The activities involved during that period of time were completion of the wastewater dump, the crew dumping excess water produced by the fuel cells and stored in a storage tank on the spacecraft. They dump it down to about 10% of its quantity or its capacity, and also completed one other routine housekeeping activity. That was cycling the film in the panoramic and mapping cameras contained back in the service module, scientific instrument module bay. That bay, of course, still has the door over it. The door will be jettisoned before going into orbit around the moon. Exposing those cameras for use in lunar orbit, taking high resolution and very accurately controlled mapping cameras, mapping photos of the lunar surface. The cycling of the film is made necessary by the fact that the film is under some tension in the magazine and the transport mechanism. This tension tends to put pressure on the emulsion, and if the film is not advanced 4 or 5 cycles, at least once every 24 hours, it tends to create striations in the emulsion, and this is done during the translunar coast when the cameras are not being used periodically once a day to prevent these striations from developing in the emulsion of the film. We'll replay that accumulated tape for you and then continue to stand by live.
Then you're going to want to cycle some film here?
That's firm. We're planning on it. Let me make sure they're ready, though, before you do it.
Well, I didn't want to bring it up, but you're about 20 minutes late on your cue.
You must have missed our first call.
I probably did.
Jack, we're ready for the pan and mapping camera film cycling. You haven't started into the procedure yet, is that correct?
No, not yet.
Okay, at your convenience, we're ready to watch you do it.
Okay, and with those last high gain, I guess they're still good, huh? You want the high gain on it?
Okay, we'd like you to use a pitch of -50 and yaw 320 and acquire the high gain.
Okay, we'll do.
You have 10% wastewater now. You can terminate the dump.
Okay, we're just about there. Okay, the old image motion is off.
Roger.
Data systems are going on. Aux TV is going to scientific.
Jack, we like auto and narrow on the high gain.
There you go, okay.
Thank you.
Okay, smack power is coming on. Backing camera is going to standby. Stock action red. Okay, mode is verified and standby. Pan camera mode, yeah. Okay, pen camera is going to power now. Variable. Brandy. Okay, the pen camera just went to power. Okay, Ron's talking to you. I didn't know that.
Thank you.
Pen camera self-test is going to heaters. Hi, bit right. Okay, waiting your cue, Gordy.
Okay, stand by. Okay, Ron, we're ready for the film cycle.
Okay, mapping camera is going on. Okay, pan camera self-test is going to self-test. Talk Max barber pole. Okay, I forgot to time it, yeah. Okay, talk back went gray on the pan camera.
Thank you.
Okay, pan camera power is off. Okay, mapping camera is going off. Okay, smack power is coming off, huh? Okay, Houston, film cycling is complete.
Okay, and it looked real good on both cameras.
Very good. Okay, Gordy, if your friends on your left, they're wondering what strange sounds they're hearing, I just got the harness on.
Right.
And I guess if you're through with the high gain, I'll go back to Omni Bravo.
Okay, we concur with that idea.
And if I could ever get Ron out of the kitchen with getting into PTC.
Jack, you'll be glad to know your heart's beating normally. Yeah, we have a good signal.
Just so long as it's beating, Gordy. About 20 hours ago, I wasn't so sure. Gordo, we're maneuvering into the PTC attitude now.
Okay.
Houston, Apollo 17, any recommended quads for damping PTC racing?
Stand by on that, Ron. We'll give it to you in a minute. Ron, we're recommending AB for damping and Bravo Delta for roll spin up. I'll say again, Alpha Bravo for damping and Bravo Delta for roll spin up.
Okay, Robert, and welcome back aboard.
Roger, sir.
You know, this eating in zero G is not so bad if you keep your bags right side up. If you keep it that way, you get the right perspective. But there's sure something funny. You turn the bag upside down and it still doesn't fall out, you know?
Roger.
Having a little beach ambrosia for a snack here.
This is Apollo Control. That completes our replay of accumulated tape. We'll now stand by for any live conversations with the crew. One thing additionally that we get out of cycling the cameras, the panoramic and mapping cameras, is an indication of how they're performing mechanically. And as you heard, based on the telemetry data that we got here on the ground, both cameras appear to be functioning properly, tucked away in the scientific instrument module bay of the CSM. You also heard some conversation with Jack Schmidt, who is wearing the biomedical harness. During sleep periods, it's customary for one of the three crewmen only to wear the biomedical harness, which allows us to get heart rate during the sleep period. And the crewmen take turns wearing that biomedical harness during the sleep period. We're getting good biomedical data, good heart rate data on Schmidt at the present time. Also, Ron Evans commented on getting the spacecraft in the PTC attitude. Essentially, this attitude has the spacecraft oriented at right angles to its direction of travel, right angles to the Earth-Moon plane, so that the sun is essentially shining on the sides of the vehicle, of the CSM and LEM. And then using the reaction control system thrusters on the command module, they set up a slow roll rate so that the two vehicles dock together, rotating at the rate of about 3 revolutions per hour. And if this is done properly, and it's a tricky maneuver, usually crews get more and more experienced at it as they go through the mission and tend to have the most problems early on in getting it set up. But if it's set up with all of the rates damped and everything very stable when the roll is started, it'll maintain this roll without wobbling out of it throughout the rest period. And the purpose of this is to maintain proper thermal equilibrium on the spacecraft, so that the heating on one side from the sun, the cooling of the other as it's exposed to the black of space is uniform and nothing gets too hot or too cold. At the present time, Apollo 17 is 84,482 nautical miles from Earth, and the velocity continuing to decrease gradually down to about 5,824 feet per second, just a little over 1 mile per second. We'll continue to stand by live now for any conversations with the crew. This could continue to be a relatively quiet period based on Ron Evans, or I guess it was Jack Schmidt's comment that Evans was in the kitchen. Leads us to believe that they're probably getting ready to eat. This is Apollo Control at 19 hours 45 minutes. This is Apollo Control at 19 hours 51 minutes. On the telemetry data that we have here in the control center, we're watching as the spacecraft is automatically killing off its rates in preparation for setting up this passive thermal control mode. Getting the vehicles very stable, and they're measuring rate changes in thousandths of a degree per second, and when it is as essentially as stable as it appears possible to get it, they'll then fire the thrusters to begin rolling it in this slow 3 revolutions per hour rate. This is the second passive thermal control mode established.
The rates are looking good. They're damped adequately. We're ready for spin up.
Okay, Bob.
The crew set up the spacecraft in the passive thermal control mode before their previous sleep period and experienced no difficulties, and they appear to be going very smoothly in this passive thermal control setup. You heard Capcom Robert Overmeyer, who's come in to relieve Capcom Gordon Fullerton, advise them that the rates have been killed off sufficiently to begin rotating the vehicles now.
Okay, Gordo, we're in PTC. Or Bob, I guess you're down there now.
Roger, Gene.
Bob, did you ever find out what part of Antarctica we were seeing at various Earth orientations?
Jack, I tried it this afternoon and I couldn't get hold of anybody, and I looked on a map for a while, and I'm not sure where Little America was, and can't truthfully say I did get it. I'll keep looking at it.
Okay, at any rate, it looks like there's a very well-developed front coming out of the northwestern portion of Antarctic ice shelf. And let's see here. Well, stand by one.
Roger.
Have to change windows. Okay, Bob, that front looks like it starts and develops as a small it actually seems to start with an anticyclone development off the coast of Antarctica. Moves up across New Zealand, looks like the South Island primarily. A little bit of the North Island is still visible. And into the eastern coast of Australia. And I'll give you a spot where it intersects. And crosses the whole of Australia. However, it breaks up and is not very well formed once it gets inland away from the coast. I see no well-developed waves on it at this time. So it's hard to say how strong it is. There might be one developing just to the south of New Zealand, or right off the coast of New Zealand.
Roger, I copy that, Jack.
There at least is some sinusoidal motion or appearance to the front where it's approaching the station. And you'll have to wait because I lost it again.
Roger.
I took two 250 millimeter pictures. Mag November is on 132.
Roger, November on 132. Those are pictures of the...
and that was at...
Jack, Houston, were those pictures of those fronts you were talking about?
That was Jack Schmidt giving us the description of the weather patterns developing off the northwest coast of Antarctica and extending up towards New Zealand and Australia. Apollo 17 at the present time is about 85,500 nautical miles from Earth and situated over the South Pacific. The spacecraft now essentially fixed with respect to the Earth and Moon, but the Earth rotating beneath it, and as the Earth rotates...
Our orbital map out now, and that front is going off, crosses the coast of Australia, north of Sydney, and largely a little south of Brisbane. And swings across the whole of Australia and seems to come, as near as I could tell, go back into the Indian Ocean about, well, where the Great Sandy Desert intersects the northwestern coast of Australia.
Roger, Jack. '17, I've got a flight plan update here.
Stand by, please.
Right, it's just a short one, one item to change.
Wait a if you saw my hands right now, you'd know why I said wait one.
I understand. I'm just waiting for your call. Just didn't want you to think we're going to give you a whole rafter of it.
Well, we know you wouldn't do that.
If you're eating, Jack, just go ahead and eat. This is nothing that we can just wait any time. Just go ahead.
Yeah, I'm not panicking. Okay, Bob, go with the update and LEM CM Delta P at 20.
Once you know it, Jack, we just cut out by the antenna switch and say again the LEM CM Delta P.
Okay, 0.6 at 20 plus 09.
Roger. Okay, my update is just simply on the bottom of page 3-23 at 2300 hours in the flight plan, or 23 hours in the flight plan. Waste stowage vent valve closed, just delete that one and move it over to 2430. That's because you got started late on that.
Okay, you could just move it.
Just change it down to 2430.
2430. Okay, Bob, revision 1 on my previous discussion of the weather around Australia, that front does cross, probably Brisbane is probably cloudy. It does cross about that area. And however, there is a bank of clouds that runs off of it down the coastline, so Sydney is either cloudy or has some pretty nice clouds off offshore. And the remnants of the front as it dissipates in the hinterland of Australia dies out at about the Great Sandy Desert, and there's not a good indication that it crosses into the Indian Ocean. But we're getting over near the limb, and that's a little hard to tell.
Roger.
Now, it looks more and more like there's a cyclone circulation developing right over the top of New Zealand, the South Island, I think. And now I'm looking with a binoc, and it's much that anticyclone circulation is centered on the ice shelf, and I think that, well, I just don't know. I think that's a Ross ice shelf, but I'm not sure, off Antarctica. And the clouds from that circulation do extend over the ice shelf and barely onto the Antarctic continent.
Roger, Jack.
Now, to the north of Antarctica, let's see, now, I'm going to give you a better orientation than that. But anyway, there is a large cyclone circulation pattern that has its southern extremity right on the edge of the ice shelf. And that is east by 20 or 30 degrees of longitude of the front that I just was discussing, or where that front intersects Antarctica.
Roger, Jack.
Between New Zealand and Australia, the front I was discussing previously has some fairly strong transverse cloud patterns. It's hard to say whether they're high cirrus or not, but the clear area to the south of the front suggests that maybe the jet stream is roughly paralleling that front in that area.
Roger. I'd have to look up and see if they do have a jet stream down there right now.
If I had to guess, if you were flying west from Sydney this afternoon, you'd have a pretty strong tailwind behind you, Bob.
Roger.
See, did I get that right? Would you believe a headwind?
Okay, I'll believe that.
But the bulk of Australia is very clear, all the south and the north. It's just that one line of clouds that crosses the center section.
Roger.
That put all the major cities of the south, Perth and Adelaide, at least, in Melbourne, certainly in the clear. And in the north, Darwin and those areas are very nicely clear today.
Roger. I hope we can get this out to them and let them know that you're watching and tell them how good the weather is.
Oh, that's all right. I'm just having fun, Bob.
I understand. I imagine they'd appreciate it, though.
Bob. I tried to pick out the Hawaiian Islands on that last little turn here through window 5, and I can't say that I did. I think I've got them, the area spotted. It looks like they might be under some fairly heavy cloud cover today. I do not see the islands. I'm not sure I could if it was clear.
Roger. Hey, Jack, I got some answer to your question from last night on where Little America is with respect to on Antarctica.
Go ahead.
There's a indentation that looks like a gulf. It's called the Ross Sea, and on the northwest edge of the Ross Sea is Little America. That's the location of it.
That would be the coast of Antarctica that sort of faces New Zealand and Australia. Is that correct?
Negative. According to the map I've got, it's the Ross Sea. Looks like it'd be more facing up towards the South America area. It's actually kind of facing up, sort of in the middle between Australia and South America, Jack.
Okay, Bob, you cut out, and I presume you meant that the Ross Sea was facing north, sort of the Pacific between South America and Australia?
That's affirmative, Jack. It's a very sharp indentation, or sea, or gulf onto the Antarctic.
Okay, I think I know the area you mean, and I'll check it out again when it comes by.
Okay, that's Little America on that northwest edge of that Ross Sea. That's where Little America is.
Yeah, all those names are familiar. I just have forgotten my geography. I'll see if I can recognize it.
This is Apollo Control at 20 hours 45 minutes. We're occasionally picking up a bit of noise on the air-to-ground circuit. This is due to the fact that the spacecraft is in the passive thermal control mode. As it rotates, we're gradually losing contact through one of the Omni antennas and reestablishing adequate signal strength on another one. And as it moves from antenna to antenna on our coverage, we get the noise. This is a characteristic that becomes more pronounced as the spacecraft gets farther and farther from Earth. Here in Mission Control, the Flight Activities Officer has been actively involved in figuring out how, in the flight plan, we're going to make up for the 2 hours 40 minutes difference from the flight plan liftoff time and the actual liftoff time. One of two things happens when you lift off late for a mission. Either the events that are called out in the flight plan occur at a different Earth time, Central Standard, Eastern Standard, or Greenwich Mean, whichever reference you happen to be using, or the elapsed times change. And the flight planning is all done in terms of elapsed time for the most part. Events that are called off in the flight plan are listed by the amount of time that has elapsed from liftoff. At the present time, in the Apollo 17 flight plan, the amount of time that has elapsed since liftoff is unchanged from the pre-mission flight plan time. However, as by the time we have approached or reached the moon, because of the speeded up translunar coast time occasioned by slightly faster or slightly greater amount of energy that was put in during the translunar injection burn, we'll have to make up 2 hours and 40 minutes. In other words, we'll be arriving at the moon 2 hours 40 minutes earlier than the flight plan allowed for. This means that all of the events that are called out in the flight plan to occur between now and lunar arrival have to be accomplished in 2 hours 40 minutes less time than the flight plan allows for. This creates no serious problems because it's a relatively quiet period of the mission. It's very easy by adjusting sleep periods slightly and moving the activities up to accomplish it. However, the flight planning officer, flight activities officer, prefers to accomplish this shift in 2 increments rather than in a single one. And this could be likened to a change of daylight savings time, where you don't want to make the jump too big at once. You might start interfering in a way that would be noticeable, say with sleep periods. But by accomplishing it in 2 segments, the change is relatively insignificant. And what this amounts to is that at 2 different times in the flight plan, we'll read up changes to the crew, and they will go down the flight plan, moving a series of events approximately 1 hour earlier. The second time that this is done, they'll actually be moving events 1 hour 40 minutes earlier, and at the same time we'll update the clocks in mission control, the ground elapsed time clocks, which serve as the key to where you are in the flight plan to agree with the changes that we have made in the flight plan. And from that point on, the GET clock will then be back in synchronization with the flight plan. This clock update is presently scheduled to occur at 66 hours ground elapsed time, or rather at 67 hours 40 minutes ground elapsed time, and we'll move the clocks to 66 hours. Apollo 17 at the present time is 88,091 nautical miles from Earth.
Checking on Ross Sea, and if I've got her pegged right, it's got a fair amount of open water in it this time of year.
Roger.
Although it's completely surrounded, I think, by portions of the ice pack. And off to the west of there, it looks like there's an area that might be clear of snow. And does my memory serve me correctly that that's where McMurdo Sound is, and some of the dry valleys?
I believe so. That's the Little America area right now, all that general vicinity, Jack.
Okay, it looks like the prime recovery area in the Samoa Islands region is clear, and my guess would be from the fairly subdued zero phase point that they might have fairly nice seas out there. Boys on Ticonderoga are probably enjoying themselves immensely, I hope.
Roger.
Indonesia looks like it's having a nice day, with a possible exception of the region over just north of Australia. New Guinea in that area, there's some clouds in there. I can't tell whether they're high or low clouds, though. They look like they're probably fairly high clouds. But north of New Guinea, there's a strong concentration of clouds, although small. It looks fairly dense, like there might be a little tropical depression in that area.
Roger.
The folks at Carnarvon ought to be enjoying a very nice day. I've been trying to spot tropical storm Teresa, which is a couple days ago was near the Philippines, but I don't think I quite have that visible to me right now.
Roger, Jack. Say, you might want to put something in the back of your mind here a minute. We made a run of the DSC recording just now of the TLI to get an idea of the quality of the DSC recording, and Gene came through loud and clear. Ron was very weak and almost unreadable, and we never caught you, Jack, in there. Maybe you weren't saying anything during TLI, but we never did catch anything you said.
Okay, I don't recall talking too much during TLI.
Right, to understand. Now, Gene came through real loud and clear, so whatever technique he was using went on that tape real well. Hey, Jack, Houston.
Hello.
Hey, Jack, just a couple of more comments on that DSE. I think, as you well know, it's very critical on the position of your booms there, and those areas that you're critical in. Why make sure that you've really got those beauties up, or you're talking right into it, and this really makes a difference because the DSE the volume is fairly low, and if you're muddled just the least bit, why it's going to be difficult to pick it up. So talk slow and get right up next to the mic, as I know you're doing. It's just some voices come across a little better than others.
Roger, Stu. Thanks for the comments. As a matter of fact, you probably called it just right. I think once I got the helmet off, I loosened up my chin strap, and my mic booms had moved away from my mouth some. And I'll keep that in mind. Thanks for the reminder.
Yeah, that's probably the most critical item is the position of those, and this has been true of in the past, and it just really makes the difference in that being able to pick up the data off the voice.
Roger, Ron and I did some experimentation with that in the chamber, and couldn't agree more. But I sometimes don't remember it. Thank you.
Well,
I just thought Okay, go ahead, Stu.
No, I was saying I was sure you're aware of that, but I think the fact that the volume is down just accentuates the problem.
Okay, Gene had something you want to ask you. Stu, I just thought you'd like to be aware of it as much time as we've all spent down at the Cape. Probably May is one of the nicest months down there. However, having had the opportunity to be up here during May, I find out that it's not nearly as nice up here.
Okay.
And I'd like to thank all my friends for that.
Okay.
is Apollo Control at 21 hours, 3 minutes. Things continuing to progress smoothly and very quietly here in Mission Control and aboard the spacecraft. And we'd like to have a bit more discussion of the ground elapsed time update. After first making the disclaimer that GET clock updates are not done for the purpose of confusing people, although I'm sure it seems that way at times. And by way of clarifying the previous description of this GET update, we should point out that the amount of time that the clocks are changed, both here in Mission Control and aboard the spacecraft, will be 2 hours and 40 minutes. And this clock change is scheduled to occur, as mentioned previously, at about 65 hours ground elapsed time. In other words, when the clocks here in the control center and the clocks in the spacecraft, keeping track of the time that has elapsed since liftoff, reach 65 hours, they'll be arbitrarily jumped ahead 2 hours and 40 minutes, so that at that point the clocks agree with the flight plan. However, in order to account for these 2 hours and 40 minutes, which are suddenly going to disappear from the amount of time available to the crew to accomplish their activities, to make it easier on the crew, it'll be done in 2 increments. The first increment of 1 hour and the second increment of 1 hour 40 minutes. And at about the time the second increment of changes is made in the flight plan, we'll also simultaneously update the clocks. Apollo 17 at this time, 88,909 nautical miles from Earth, and the velocity continuing to decrease gradually down now to 5,603 feet per second. Very little activity scheduled in the flight plan between now and the time the crew begins its rest period. This day aboard the spacecraft has been planned as a relatively short one, recognizing that the crew would not get a great deal of sleep on that very long, as a result of the very long launch day and relatively short sleep period following. This day was intentionally kept short. They're now should be completing their eat period, although they really have nothing showing in the flight plan until about 22 hours, or about another hour from now, where they have allotted time for exercise. They'll be changing the lithium hydroxide canisters that remove carbon dioxide from the spacecraft cabin atmosphere. They'll be realigning the spacecraft platform, the stable platform that's used as an attitude reference by the guidance, navigation, and control system. Then they have one more eat period and go through the pre-sleep checklist, beginning an 8-hour rest period at about 25 hours ground elapsed time, or a little less than 4 hours from now.
Bob, you with me?
Roger, we wouldn't go away, Jack. We're listening. Did you call?
Well, I just, I almost lost the pass here. Just a couple more words about Australia. As a general landmass, it's red. Very strong red hues, except for the north and eastern coasts, where that red gradually merges into a greenish gray. It's as red as portions of northern Africa appeared to me yesterday.
Roger.
Very striking color. It'd be more of an orange red, really, with the brown subduing it. It's not, obviously not crimson or anything like that.
I think it's a function of the sun angle, Jack, or is it just the red that, like we see out in New Mexico area, sometimes some of the areas?
Yeah, no, it's not sun angle, because that'll hold a good red color right in towards sunset or sunrise. It's due primarily, I'm sure, like most desert areas, to the oxidation of the iron-bearing minerals in the sands and rocks of those regions.
Roger.
Getting limonite, hematites. Little geology thrown in there, Bob, sorry.
That's all right. Got to keep you warmed up for the next couple of days.
Well, I think the flight plan will probably keep me warmed up, too.
Roger. We thought that time around T&D was just outstanding.
Hey, Bob, I think we pretty well got impressions from you down there on that night launch. I might give you a few of mine.
Go ahead, Jane. Right on the edge, if you read me, we're getting a lot of static. You just hang on a minute, we'll be back into some comm here. Jane, Houston, go ahead. Houston.
Go ahead.
We're just standing by for your comments you want to make. I think we lost comm there a minute. We're back with you.
Okay, Bob. The entire boost itself was not unlike what you've heard and what Stu down there understands from the physical cues and what have you, but the significant part of going that night is that as soon as we did have ignition down there in the bottom of the S1C stack, even though I only have a little slit out of the rendezvous window here, and Ron doesn't have much of a hole in a boost protective cover out of the hatch window, we could definitely confirm ignition because we could see the reflected light on out through in front of us. It was by no means blinding, of course. We had the cockpit pretty well lit up. As soon as we lifted off, that light immediately went behind us. We came in at S1C staging, and I had an opportunity to say I told you so to Jack and Ron. It was just like the great train wrecks of the past. I definitely could see the S2 ignite, and then of course I could see the significance of the reflection through the window. Besides all the other cues we had for ignition, very much like the S1C lit up the windows on the stack. Tower jet was pretty spectacular. I could see the entire boost protective cover and some flame from somewhere, I'm not sure. Maybe it was through the hole in the windows, but I could definitely see it. Of course, it disappeared in short order. When the S2 shut down, the delay time between shutdown there and the S4B igniting, the entire flame overtook us, and we literally flew through the S2 flame when the S4B ignited. If you can imagine that, it's very similar to the Titan staging where you actually fly through the fireball on the S2. And that's something you never see. None of those things you ever see quite that way in daylight. On the S4, I could see, of course, once we got going, couldn't see any light from the plume again, but we could see the apps firing all the way through the burn. And once we got in orbit, as other guys have seen, you can see the apps firing at night without any difficulty. One of the most significant things about TLI is the fact that we, of course, started at night and flew right on up and through a sunrise, which in itself was a pretty spectacular thing, but when you do it during a TLI burn, it even adds a little bit momentum to your effort.
Roger, Gene. Any comment you might make on the possibility of picking up your yaw if you had lost your platform at that time? Remember the discussion we had about the yaw and the late, like a mode 4 or something like that?
Yeah, Bob, I not only will comment, and I was aware of it, and I was looking for it, and during parts of the S2 and parts of the S4B burn, I even turned the lights down in the cockpit in hopes that I could see stars out there, but I could not make out a one. Ron, I think, may have saw Saturn out the overhead hatch, but looking through the rendezvous window during the boost phase and during a time-critical phase like a Mode 2 or Mode 4, I am very much afraid that we would not have been able to pick up that reference.
Oh, Roger.
As I remember it, as low as I had the interior lights there for a period of time, and I didn't want to keep them that low, of course, to see if I could get adapted very fast, because we were in the dynamic phase of the burn. But my window just gave me a very deep purplish hue, a hue of which I could not literally see through to see any stars at all. Now, that may have been due to the very low intensity of our interior floodlights.
Roger, Gene.
Bob, this is Jack. Little lay impression there. I think I saw just about everything Gene was talking about as far as his description, and felt like it was although everything was an amazing experience, each one in itself. After each one was over, you could think back and say, yeah, that's what other guys have said it was like. The old Saturn V has gotten to be a pretty consistently performing vehicle. But with the added nighttime contrast, I think it made it probably the best ride any three guys have ever had.
Roger.
Bob, I might add that the S1 was, as usual, pretty shaky on liftoff. I saw all the maneuvers, as I call them out, the yaw and the small reverse roll. Going through max Q, I got up to 25%, but my yaw attitude error was 0, and my pitch attitude error probably wasn't even at, a degree, certainly less than 2 degrees. After max Q, she smoothed out by comparison quite a bit, and the S2 was a very quiet ride, very smooth ride. However, you're always aware, due to just a little rumbling on it and the S4B, that she was still burning for you. The S4B, I think, was just a continually rumbled but smooth or consistent ride all the way through TLI.
Roger.
Gene, I think one of the big things that impressed me was the how instantaneous the decelerations were of each one of the boosters when they cut off. That included the S4 in TLI cutoff. No physical appreciation of tail off at all. And Bob, from my rendezvous, from the right-hand rendezvous window, when the tower jet occurred, there seemed to be a lot of burning particles streaming away from it. I could not see, did not notice or remember seeing the actual cover or tower itself, but we were inside the cone of the burn, and with a lot of streaming, it looked very much like a skyrocket. Portion of one at any rate. Remind me of the 4th of July out in Silver City a few years ago.
Roger. Say, anytime you got your flight plan handy, I've got a discussion here I'd like to run through with you on the how we're going to recover this 2 hours and 40 minutes from the launch delay, and you'll need to copy it into the flight plan. And then just want you to be advised, we're not happy with the PTC. We've got a half angle of about 17 degrees, and so sometime after the P-52 coming up at 2300, we'll want to do another PTC, or initiate PTC again.
Well, that was a commander-initiated PTC, and I've already heard about that. You bet it has. Okay, we got the flight plan here, Bob. Which part of it you're talking about?
Well, let's just talk some words here for a minute, and then I'll go through some specifics that you can just write down on a page, because you don't want to do it until a little later. Okay, what we're going to set up here, you will arrive at lunar orbit at the same GMT time. The landing, sun elevation angle, and the camera settings and everything will be unchanged when you get to lunar orbit. To compensate for the 2 hour and 40 minute late launch, we're going to hack 2 hours and 40 minutes out of the timeline, and we're going to, they'll be out of this TLC timeline, and we're going to do it in two groups. And this is where you might want to start copying now, Ron. Delete 1 hour from 46 to 47. From 46 to 47, we're just going to delete the activities that are presently scheduled at 4630 to 4700. You'll perform at 45. Move those to 45. Let me read that again. Delete 1 hour from 4600 to 4700. The activities that are listed at 4630 to 00, perform at 4500.
Okay, Bob, looks like we'll delete 1 hour from 46 to 47 hours, and then the activities that are at 46:30, we'll do those at 4500.
Roger, Ron, and then starting at 47, just just scratch 1 hour off of each time, just subtract 1 hour from each of those times up through 66 hours. Just subtract 1 hour from 47 up through 66.
Okay, we can do that. Subtract 1 hour from 47 through 66 hours.
Okay, and then just for your information, you won't have to do it, but we're going to play the old simulator step-ahead game at 66 hours of the old time, which will be 65 hours of the new time, or however you want to call it. We'll call you, and we're going to sync you up at 6740 at that point. We'll play the old step-ahead game there.
Okay, Bob. All right, that means that you're not going to actually do any clock updates or syncs until somewhere in the 60s there, not in the 40s.
Roger, it'll be 65 hours on the new time or 66 hours on the old time, depends on you will look at, but that's when we'll sync you up.
Okay.
You'll be in sync all the way out to that time. Just we're just going to delete and jump you to 6740.
Okay.
And just another note of interest, you don't have to write this down. Let me see, I'll read it to you. The awake periods will be on day 3. You'll be 15 hours, 8 hours sleep starting at 11:33 CST. Then at day 4, you'll be 14 and 20 hours with 8 hours sleep. So it actually just shortens a couple days there.
Okay, mighty fine.
The beauty of that Tommy came up with on that, Ron, is that all you have to do is go subtract those 1 hours and no more reading or anything else, just subtract them and we're in business.
Yeah, it looks real fine.
We're going to give Tommy a gold star for that one.
You bet. Bob, this is Jack. I'm going to try to get a little exercise. I'd be interested to know how high I get my heart rate just fooling around up here.
Okay, if we can... We'll keep you posted, Jack.
Bob, just to keep you and people there thinking a little bit, today is a relatively short day, but it's a good day because it gives us a chance to, again, get acclimated, finish our stowage, and just generally go through all the things that have to be gone through for the rest of the mission. We've got 3 eating days today, and judging from what we're thinking and talking about now, that the last 2 are going to be sort of stretched into 1 eating period, because 3 meals on this particular day just is not really going to be stomachable.
Roger, we understand that.
I think you'll find out that our eating and drinking, for the most part, is starting off relatively slow, but I think we'll pick it up here by tomorrow.
Roger.
Bob, one other thing while I'm thinking about it, the PU shifts were all noticeable, but probably the one that really caught me a little bit by surprise was the PU shift on the S4B during TLI.
Roger.
It just felt like you lit any other burner.
Roger, understand. Just for Jack's information, you're running in the 80s on your heartbeat. We saw a 91 or 2 there for a few minutes. Are you still working out?
Yeah, that's sort of discouraging.
Sorry, babe.
Hey, Bob, what was Jack running before he started that?
He was running in the 60s, a constant, somewhere in the mid-60s.
Okay.
Okay, Jack, you're running about 105 and 103 right now. Kind of interesting, Jack. You slow down and then you're back up to 105 right now. Now you're slowing down again.
Flight surgeon John Ziegelschmidt is watching the heart rates of Jack Schmidt as Jack exercises aboard the spacecraft using a modified exerciser. It consists primarily of a cylinder and a cord that comes out of it. Allows him to adjust the amount of tension or resistance to pull that the device has, and there are a variety of ways in which it can be used. Allowing him to pull against the adjustable tension of this bungee-like device. And he's gotten his heart rate up somewhat in excess of 100 beats per minute.